Page 249, section 5.1, we're going to do numbers 24, 26, 28, and 30. We're going to find the area indicated, the indicated area under the standard normal curve. And so for number 24, I asked you to find the area to the left of z equals 1.28. We're always going to start with our 0 right here. And this is just like a number line to the left and to the right of 0. Negative numbers here, positive numbers here. So 1.28 is going to be right somewhere on the right-hand side, 1.28. And so if it says find the area to the left of it, it's going to be this piece here plus this piece here. Well, the curve is actually broken in half by the 0, that the area here is always going to be 0.5. So in this case, we're going to add 0.5 to whatever we get when we look up 1.28, because I use the alternate method. So let's take a look at our table here to help us find it. So we're going to be looking up 1.28. So we go down to 1.2. and over to 0.08 for our hundredths place. And so that's going to end up giving us 1.28 is 0.3997. So we're just going to add that to the 0.5, 0.3997. So for number 24, the area to the left of 1.28 is 0.8997. Let's take a look now at number 26. We were asked to find the area under the curve to the right of negative 1.95. So again, our 0 is right here in the middle, and negative 1.95 is going to be on the left this time, and we're going to find the area to the right of it. So that's going to be this piece plus all of this, and the curve is one whole, so half the curve is going to be 0.5. And so we're going to look up negative 1.95, which is just going to be 1.95 because it's the same as negative 1.95 in our table. So 1.9 is going to be down here, put on the ones in the tenths place, and then over to the 0.05 will give us 0.4744. So we're going to add the 0.5 plus this area right here is going to be 0.4744. And so we add those together, we're going to get 0.9744. So the area under the curve to the right of negative 1.95 is going to be 0.9744. And so next, let's look at number 28, which asks us to find the area to the right of 3.25. So we've got our 0 here in the middle, and the 3.25 is going to be way on the right-hand side. It's going to be our 3.25. And so we're going to find the area to the right of that, which is what we call a tail over here. And so we know the area from here to the end and forever is 0.5. Well, our table is going to tell us this area here. It's going to tell us from this all the way to this, all of this area. But we don't want that. So we're going to take 0.5 and we're going to subtract what we get. So let's look up the 3.25. So we're going to go down to 3.2 for the ones and tenths place, and then we're going to go over to the 5 here. So 3.2, 0, 1, 2, 3, 4, 5. And that's going to give us 0.4994. So we're going to take our 0.5 and subtract that 0.4994, and with a bunch of zeros and borrowing, you end up with 0.0006. It's pretty small because most of your data is going to be within 2 standard deviations. So for number 30, we're asked to find the area under the curve to the left of negative 3.16. And so first of all, again, our 0, the negative 3.16 is now way over to the left-hand side. And we want to find everything to the left of that. So there's another tail. And again, our table is going to give us from here to here that we don't want. So we're going to do 0.5 take away what we get when we look up that 3.16. So let's look that up. So it's going to be 3.1 and then over to 6, 0, 1, 2, 3, 4, 5, 6 gives us 0.4992. So we're going to subtract that from 0.5 and we end up with 0.0008. And your area that you shade should look pretty similar to what you're coloring in. Like this is a pretty small amount, that's a pretty small amount. This is a much larger amount, and this is even larger yet. And so you want to make sure that your area goes along with what you're shading. On page 247, section 5.1, try it yourself 6. I picked this one because it wasn't a homework problem like this for the basic type stuff. And it asked you to find the area under the standard normal curve between z equals negative 2.16 and z equals negative 1.35. And so this is going to be the same whether they're both negatives or both positive. You're trying to find the area between. So let's take a look at where these two are. So negative 2.16 and negative 1.35. Well, negative 1.35 is going to be closer to 0. So this would be negative 1.35. And then negative 2.16 is going to be further away. So what we want to find is the area between these two pieces. And so when we look up in the alternative method in Appendix A, negative 2.16, what we'll get, and we'll do that over here, what we're going to get here, if we look up negative 2.16, is the area between 0 and negative 2.16. So when we look that up, it's going to give us this area right here. Okay? So let's look up that negative 2.16 and see what we get. So when we go to Appendix A in the alternative method, we just look up 2.16. So we go, ones is 2 and then 0.1 for the tenths and then 6, 2.16. So we get 0.4846. So we get 0.4846 for this area. Okay, now we want to also look up that negative 1.35, which is going to be, it's going to give us the area between 0 and 1.35, negative 1.35. So when we look this up, it's going to give us between here and here. So let's look up that negative 1.35 or that 1.35. So we go down to 1.3 and over to 5, and we'll end up with 0.4115. What we want is we want this area here, this area 0.4846, but we want to take away the area here 0.4115. And so the area that we do want is the green without the orange. We want this right here. So what we're going to do is we're going to take the 0.4846 and we're going to subtract the 0.4115 to find the area in between. And that's all you're going to do, is you're just going to take the 0.4846 and subtract the 0.4115. And that's going to give the area between the two negatives, or if they were two positives. So here we'd end up with 0.0731. So whenever you have two positives or two negatives, when you're trying to find the area in between, you just need to subtract their areas after you look them up.